In this presentation, Dr. Eric Katsuyama elucidates key concepts of ANOVA and its significance in clinical research.
Currently one of the teaching assistants of the PPCR program. So today I'll be talking about a very important topic that is the statistical test number 3. And basically we'll be talking about today about ANOVA test and similar tests to it. So let's begin our presentation. ANOVA stands for analysis of variance. And when should we use ANOVA? Primarily, ANOVA is used when we want to compare more than 2 levels of independent variable. For example, when we want to compare 3 different groups. So we'll give an example when we want to compare CGLT2 versus beta blockers versus placebo in patients with heart failure. Evaluated the outcome of BMP levels, that would be your dependent variable. And when we want to add another variable to analyze, to adjust our results, or also to between these 3 groups, we want to analyze the different types of gender, male and female, for example. So the first thing you must understand is that the null hypothesis for the ANOVA is there is no difference between the mean of the groups that we are comparing. And the alternative hypothesis is that at least one of the means between the groups is different. And let's go to the assumptions. So the first assumption that we must have is that the dependent variable are with continuous data. And another thing is that our population must be normally distributed. We also must have the homogeneity of the variance and have independent observations. So this will be output that you might have in the data. And here, when we are talking about the homogeneity of the variance, we are talking about that each group must have similar variance among the participants of each group. So how do we test that? We use the bullet equivariance test, and this test must be higher than 0.05, so it confirms our null hypothesis. And basically, the ANOVA test will differently. Another important aspect to understand about the ANOVA versus the t-test, the ANOVA will compare the means based on the variance, not directly with the mean as the t-test does. So the output in Stata will show the most important things, that are the degrees of the freedom, the p-value, and the f. And we have another methods that we can use. We can use ANOVA. So in my example of patients with heart failure with different types of drug, we can also add the independent variable of age, and we adjust this variable, adjust our analysis with age. The two-way ANOVA is different. We are going to put a categorical independent variable. So for example, patients with more than 50 years of age or less than 50 years, and we're going to stratify the results of each group based on the age also. And we have the ANOVA repeated measure that we compare variable in multiple conditions or time points with the same subject. So for example, we are going to observe our patients in the week 1, week 2, and week 3, and repeat the ANOVA several times. If we do not have the normal distribution of data, we are dealing with one-way ANOVA, you can always use Hankin-based non-parametric tests as the Kruskal-Wallis test or the Friedman two-way ANOVA. And we also can use post-hoc analysis to estimate our effect, because as said, our null hypothesis for the ANOVA test is that we do not have difference among the different types of group. But if you want to see if A is better than B, or in my example, CGLT2 is better than beta blocker, or beta blocker is better than placebo, we must do some post-hoc analysis using both Fehoni test that is a more conservative test that will decrease the type 1 error. And if not, we can use the Tucker's method that compare the mean from all the groups without making any adjustments. So basically all the figures that I used were using the questions and answers book on statistical for clinical research, 262 questions for deeper statistical learning through questioning. I really recommend this book for you guys to understand better this topic. and also the critical thinking in clinical research. Thank you for your time and see you next time.